So this is another important concept from chapter 4, that is magnetic dipole moment of a revolving electron. So what we are assuming is we are assuming a heavy nucleus. Heavy nucleus is represented by Ze, where E is the charge of an electron and Z is the atomic number. So it's a heavy nucleus whose radius is r and an electron is revolving around that nucleus. When an electron revolves around the nucleus, obviously there will be a current. Okay, so electron revolves around a stationary heavy nucleus. This constitutes a current I. Now I is equal to Q by T, that we know. Over here I will be equal to E is the charge divided by T is the time period. Now time period we know it is distance by velocity. Over here it's a circular turn, so the distance will be given by the circumference 2 pi r. So 2 pi r by velocity v. So I can write I is equal to E by 2 pi r by v. V is going to the numerator, EV by 2 pi r. That will be the value for I. Now we know magnetic dipole moment. So magnetic dipole moment, it is represented in certain books, it will be represented using small letter m. Sometimes it will be capital letter M, or it will be represented using mu L. Okay, this is orbital magnetic dipole moment mu L. We know magnetic dipole moment is I into A. So for current I can substitute EV by 2 pi r and the area will be pi r square. Over here it is a circular, the nucleus is of circular shape. The radius will be r, so the area will be pi r square, and R will get cancelled, pi will get cancelled. So finally what happens is EVR by 2. Over here I will multiply numerator and denominator by m. Why? Because mvr is angular momentum. Linear momentum is p, that is mass into velocity. When it is coming to the circular motion, it will be angular momentum and it will be mvr. So over here mvr, so for that I will multiply numerator and denominator by m. So for mvr I can substitute L, angular momentum. So you will get El by 2m. Now what I'll do is L I will take to the left side. Okay, so mu L is equal to El by 2m and L I will take to the left side. So mu L by L is equal to E by 2m. You will get it as E by 2m. So that means magnetic dipole moment per angular momentum, that is actually known as gyromagnetic ratio. So the ratio of magnetic dipole moment and angular momentum is known as gyromagnetic ratio. And here there is a negative sign. The negative sign shows mu L and L is in opposite direction. The direction of magnetic moment and angular momentum will be in opposite direction. So that is being represented using the negative sign. So mu L by L is equal to minus E by 2m, that is gyromagnetic ratio. They can ask what is gyromagnetic ratio. To write the value of gyromagnetic ratio they will ask. So gyromagnetic ratio means it is mu L by L. Now when you substitute for E, it will be charge of an electron 1.6 into 10 to the power minus 92 into m. M is mass of an electron, that is 9.1 into 10 to the power minus 31. When you substitute the values, you will get the gyromagnetic ratio as 8.8 into 10 to the power 10 coulomb per kg. So that is gyromagnetic ratio. Now one more topic is coming there, that is Bhor magneton. For finding that, what we will do is, to this equation we will incorporate the concept of Bhor model. So what did Bhor say? Bhor said in grade 9 you studied electron revolved around discrete orbitals. Okay, and this electrons will be having an angular momentum L is equal to nh by 2 pi. Okay, the angular momentum of electrons revolving around an atom will have an angular momentum which is equal to nh by 2 pi. That was Bohr's explanation. H is Planck's constant. So when I substitute that value of L for our angular momentum over here, so mu L is equal to L by 2m. For L I will substitute nh by 2 pi, so E nh by 4 pi m, and all these values we will know. Charge of an electron, Planck's constant, mass of an electron, and we will consider n is equal to 1. N is equal to 1 means it is the first orbit. N is equal to 2 means the second orbit. So I will substitute for n is equal to 1, assuming it to be the first orbit. So EH by 4 pi m. I'll substitute all the values. Charge of an electron in 0.6 into 10 to the power minus 19. Planck's constant 6.6 into 10 to the power minus 34. Then 4 pi into mass of an electron. When you substitute, you will get the value as 9.27 into 10 to the power minus 24. This value is known as Bohr magneton. That means it is actually mu(l), right? It is the magnetic dipole moment of a revolving electron in its first orbit. That is Bohr magneton. This value is known as Bohr magneton. That is the magnetic dipole moment of an revolving electron in its first orbit. Okay, so that is Bohr magneton. So these two are two important topics: gyromagnetic ratio as well as Bohr magneton. Okay, thank you.